Good afternoon, good evening, or good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor Sydney livestream event and another episode of our Devs Down Under series. I'd like to welcome back for part 2, Brad McCoy and Ben Poe. So today will be part 2 of this session where they'll be setting up multi-region AKS clusters for your Azure front door. If you're joining us today for the first time, I'll just give you a bit of background on both Brad and Ben. So Brad started his career as a software engineer at TripAdvisor and then got into DevOps and moved into Fintech, where he led the cloud engineering team at Temenos as engineering manager. He is now working as head of cloud engineering at Moula and is an advocate for cloud native and open source technologies. So Ben is a former architect of physical buildings and is now transitioning into being a cloud architect for infrastructure. He is currently working as a cloud engineer with Moula, where his Azure, Kubernetes, and Terraform skill set are being put to good use. So you'll see that I have put into the comments section the check-in link for today with the event code 14256. So please do check in. You will find additional resources from today's session. We'll be speaking for about 45 minutes with 10 minutes for questions hopefully at the end. However, do send us your questions throughout in the Q&A and we will answer as many as possible. And at the conclusion, we'll also share with you guys a link to the feedback survey with the same event code 14256. And we'll also have the YouTube link there. So this one is going to be available on demand straight after today. So if there's anything that you missed, you can watch that back and we'll share with you guys the link to that one. But for now, I'd like to give the floor over to Ben and Brad to begin. So thank you both and over to you.
Great. Thank you all for coming. So today's talk, it will be, as you can see, implementing Azure Front Door with multi-region Azure Kubernetes Service clusters. Brad will be doing a live demonstration today where we have 2 separate web apps deployed in Azure Kubernetes services in 2 separate regions. And today's demonstration will be on how we can use Front Door to tie these together. So over to you, Brad. I think you're on mute, Brad.
What we'll talk about today is how Ben and I have been doing this. It's our first phase of multi-region clusters. After, when we start implementing service mesh, it will be a little bit different, but essentially we've been following this guideline here. So this is AKS. So they have an AKS baseline just for single region. And then if you want to go multi-region as well, there's a great document explaining all the best practices and almost the blueprints of how you should set this up. So the first thing that we've noticed when we started doing this is as you go multi-region, that means, essentially double your costs or more. So when we implemented this, we were trying to really go price first. So always think about, you can have all these great things, multi-region and high availability, resiliency, scalability, etc. But if it's going to cost you more than you're making, then that doesn't make sense either. So when we're doing this, we recommend that everything should be automated. So we're using Terraform to spin up this architecture diagram here. We've actually, to save cost as well, we have cut out application gateway because that could be quite expensive. So we wanted to keep costs down as much as we could. So for what we'll show you today, we've taken out application gateway and we've got a private cluster as well, which is quite cool. So the implementation is that we do a private cluster, then we do our ingress deployment, and then we no longer really need. So this Bastion service, the VM, we don't actually use that at the moment because that costs around maybe $8 a day for all that. So we actually have in Terraform if we want it or not. And if we do need to connect to the back end, we just simply say Bastion enabled equals false. And we're using Argo CD to deploy all of our applications to the multiple clusters. So we recommend something like Flux, or a GitOps model is really good for this, because you know that all your clusters are in sync as well, which is quite important. You can see here that this is our shared resources. So for container registry, you could actually have geo-replication as well. So you can have one container registry over 2 of the locations, and then for Key Vault as well. So a lot when you're thinking about implementing this as well, you have to understand that. So Key Vault, for example, will take 1 hour to failover. So you do really have to look at your failover scenario if you want to do it manual, automatic, or sort of somewhere in between. Because you want, if front door is going to fail over to your next region and region 1's down, you want your Key Vault stuff working properly as well. And yeah, otherwise pretty straightforward. We have the front door we're using is standard, so we wanted to keep away from premium for this exercise. So we're quite happy with the front door standard. And for those that don't know what front door is, it's a global load balancer. So those application gateway, they're regional. So yeah, we're using it as a layer 7 load balancer, and it only works within the same subscription. But the way we're doing it with a custom route, you can see that you can actually do it over other subscriptions as well. So yeah, and if anyone has any questions, please ask as we go. We're more than happy. And Ben, also, if you have some more questions.
Yeah. So right now you had what you had just described was more of an active and hot standby type scenario, which it can be done in both ways, whether we have an active front door scenario or active and hot standby. Could you elaborate a bit more on the differences between the two? Because you had mentioned about the failover, which would be more of a active standby type.
True. Yeah, you're right. Yeah, good point. Yeah, so there's a few different models you can use. There's probably a few I can think of. So the first one being active. So that's where your traffic is going to be routed to both regions. You know, like you can have, should we go into the Azure portal now, Ben, or we'll just talk over the different?
I think we can talk over this one. So I guess active would be more for scenarios like, say, where you're getting a lot of traffic, say your Black Friday sales or something of that sort, where you potentially one region might get swamped. So you flip it to an active scenario where traffic gets diverted to region primary and secondary at the same time. And that way one region doesn't get completely swamped. Whereas an active standby type scenario would be more of a disaster recovery thing. Say the data center in region 1 goes down, you have a complete set in region 2 that's ready to flip over at any moment's notice to handle any downtime in region 1 until it recovers. Aside from that, I guess that's
and then
main difference.
Yeah, and then the next one as well that we were discussing is if you have all of your region 2 in Terraform, if you wanted to save a lot more money as well, you could simply say multi-region equals false. And then if you did have, they do go down sometimes, the regions, but within, like, let's say 15 minutes, that's generally how long it takes to spin the cluster up, the bastion, all that stuff. You could essentially have that as an option as well, right? And then you just change your front door to, you have a little script to change your front door to the new region. So that can save a lot of money as well.
Yeah, in the active standby scenario, you could have the standby region, on a lower skew than what you would have for your primary, because if you have in an active and standby scenario, your primary will be handling 100% of the traffic, and that's the one where you want it to be at the right level, the right skew that it's able to handle it. Whereas the standby, because it's just sitting there waiting for a disaster to happen, it can be on a lower tier until it needs to be. Then it gets scaled up right before the switch over. That way, you're not burning unnecessary costs in the process while it's just sitting there idling.
And you could leverage with Kubernetes as well your horizontal and vertical auto scaling. So you could have horizontal scaling on your pods and then enable. We have auto scaling enabled on these ones, and then you can specify your min and max nodes. So I guess you can save money then, because if there's no traffic going into it, then it's sort of standing by in that, not consuming a lot of nodes as well. So yeah, a few different ways. We've recently sort of gone over a few of these as well, and I guess it goes back to cost as well, doesn't it, Ben? Like active, sounds like the best, but sometimes
if the business does not require it, it literally is double of everything. So if your business requires it, it's a good problem to have, but otherwise it's just wastage, I suppose.
Yeah, and it depends what industry you work in. If you're in fintech or something where, let's say, you have a credit card and you're doing payments, that could be the cost of the damage to your business and branding and stuff if something happened would be more than what it would cost for your Azure bill. So it depends what industry you're in, really. But yeah, that's essentially the diagram that we've followed, and then our next step after that would be implement service mesh as well. But yeah, we're quite happy with how front door works with it at the moment. So I'll pass that through to you, Sarah, and we can share that after the talk. If anyone's interested in this document, I recommend it. So it tells you a lot of things. It's a great thing to read when you're looking at things like this, because it puts stuff in your head, and a lot of the stuff we didn't think about as well. They actually have ARM templates you can use as well that will spin this for you, but we use Terraform, so we ended up essentially looking at the diagram and copying it. And then, this is talking about the GitOps as well, which we use Argo CD, which it says here, and that works really well. We actually have because it's a private cluster, the way we bootstrap it is when the Bastion and the VM set up, or the VM. So that's got a VPC pairing here, so it can connect to the private cluster endpoint. And then we use a VM extension, which will just run a bash script to install like kubectl and the things that we require. And then after that, Argo CD will take over.
And after that's done, we actually can just take batching down, because you only need it during certain times.
Yeah, because the good thing is to always look at your cost when you're doing this. Like, really write it down. How much does it cost per hour per day? And then how many times do you actually use Bastion? Like, because Argo CD does everything and we do everything in GitOps, all of our changes to our cluster are done in Git. So like, therefore, it's very rare that we would need a Bastion. So therefore, we choose not to run it when we don't need it. Only if you're troubleshooting would probably be the time that you would use it.
And that's also the perks of us having infrastructure as code, because whenever we need Bastion, we can just run that one script. It'll get the exact same identical resource deployed every time, and easily add it or remove it, and you guarantee the same results every time.
Yep. So let's talk a little bit over front door. So this particular Azure is for an open source project called Ortelius that we're working on as well. So this is the front door for them. So essentially how we've done it is where we have all of our resource groups for, this is our DevOps cluster that we use. So you can see in the US, we have East and
South Central.
South Central, exactly. And then, so both regions, and then the shared services here that span over both regions. So if we look at our front door, for those that maybe would you like to speak about front door, Ben, or you want me to?
You can go over this one. Yeah.
Okay, sure. So for front door, you have three things. So domains, origin groups, or backend pools, and routes. So the way it flows, this is your CNAME record going to your custom domain. So today's demo, we actually have, this is just using my AWS Route 53. So it's just reactor.bromccoy.io when that comes up. Okay, this is the new front door. So this one is still in preview, and in production at the moment, we're using the old one because it's not recommended that you run the preview in production yet. But they're making some great changes at the moment behind the scenes so that you can upgrade with these. So did you want to talk a little bit about the differences between preview and original front door, Ben?
Yep. So the original front door is just the front door itself, whereas in front door standard premium, this preview version, we call it front door version 2, it's added on additional features such as content delivery network, CDNs, and firewalls all packaged into one. So in a way, front door version 2 is just front door plus, you could call it. For standard, it comes with the content delivery network, and for premium, it comes with both. I believe it's both the CDN and the firewalls, and the costs that are associated with it as well. But essentially, it's this one resource that does everything, rather than in front door version 1, where you spin front door up and you add additional resources that are managed separately. And that's for standard and premium. You do get a different interface, but it still works generally the same under the cover. So if you're familiar with version 1, you'll be able to do the same with version 2. Some names would have changed, like backend pool. In version 1, it's called backend pool. In version 2, it's called origin groups. But essentially, it's just a name change. They still do the same thing of you specify where do you want traffic to be routed to, and it just sends it to those apps or endpoints.
And you can see, let's pretend to make one. So you can choose here if you want to use Azure Managed DNS, or for any other service you can do here as well. So custom domain, you will have to put the text record in your custom domain to point to this, and then the CNAME after, and then all the traffic coming in will show you next what we do with that. So I recommend that you use Azure Front Door Managed certificates because, I mean, some use cases you want to bring your own, but this works really well for me, and I let Azure take that burden with managing certificates and stuff. I mean, a lot of production instances that we see in other companies just from a silly certificate, so I'm quite happy to let Azure take care of that. And yeah, if we just put here, and then you do that, and then you go in and add your text records, and then the next thing that we want to do is probably set up a origin group or backend pool first before we do the routing. So if we look at the one we did today for the demo, so here you can have as many as you want, and then you have the concept of priority and wait. So at the moment, you can see here that pretty much we're putting all traffic to the first region. We've used this when not really using Kubernetes, but when we were using other technology. This was good for when you're updating. If you have an incident or maintenance, you can bring down the whole region and just you can work on that, and then no traffic will be sent to it. So this is an example of how you can do that. And you can see here I'm using custom. You can use, let me show you what we can use. So you can use application gateway, public IP, custom. You can put it to a service as well.
And yeah, it's quite convenient when you're trying to send things to your app services or function apps that are already existing. So let's say you have two web apps, one in region A and one in region B. Instead of manually adding the names, you can just choose, like in here, I believe it's app services that would bring up all your function apps and web apps. Similarly, application gateway or API management. These are the default things that Azure has kind of given you a shortcut to. Say, I don't believe we've got any app services in this subscription, but if we did, if you selected that, it will just bring down a list of all your apps in that particular subscription. And again, front door works for a majority of scenarios. It's within that subscription itself. So if you separate your say a prod subscription against a UAT subscription or test subscription, then that wouldn't work.
Yeah, if you're doing it this way, yeah.
Yep.
But if you did it,
otherwise you can still do the custom.
But yeah. And we have application gateways in the subscription, so you can see here, you can hook it up to the app gateway pretty easy, and then you can do public IPs. I do custom. The reason I do custom is I need a DNS name, not an IP, and that's got to do with ingress. So for my ingress object, I have host, and I need to know that it comes from reactor.browser.io. I need that to pass through into the cluster. So then my ingress deployment knows what to do. It knows what rule to follow, because, think of ingress as like a little front door inside the cluster as well that knows where to send the traffic, etc. So I would have here, let's just say it was coming from that, and then that's the host header that I need. If you do an IP, that won't work. So that's one thing I had to figure out how to do to get my ingress working in the cluster as well. And then we obviously have, because it's coming through in the domain, I'm saying give me a 50-50 split from that domain into those regions, so I can choose how much traffic I want to send. And then the last one as well is routes. So routes, you can specify a lot of things as well. Like you can do patterns to match, like paths. You can also specify the domains from the front door. So you can see I'm using the standard one here, but I don't need to. I can take that off and just use my custom domain that I'm bringing in. And Ben, is it you can have as many domains as you want, or is it limited to 50 or 100 or something? Is it?
I believe there is a limit, but it's a very high limit. That
high limit, yeah.
Yeah, reasonably, you probably wouldn't hit it.
Yeah, true. Okay.
Could you just go to the origin groups for a second? We can show how active against active standby would work. Sure. So right now in this reactor, you see this as 51. Technically, this is still an active. It just sends, like, say, about 2% of the traffic roughly to one region and the other 98% to the other region. So if this were to be an active standby type scenario, what you would then do is if you clicked on any one of those host groups and instead of enabled, you take it as a disabled thing, then that would send 100% of the traffic, rather than right now we've got a minuscule chance of still going to region 2.
Yep. And then you can also enable health probes as well. For this, I didn't, because with health probes, they like ping it, like, what is it, like probably 10 times a minute or something crazy. So we didn't want that logging, and it makes it difficult to do debugging as well when you're working it all out. So health probes also will help you to fail over, well, not fail over, but direct traffic if the health is not, if it's not healthy on one of those regions. And generally front door will send you to the region that's more closest to you. So that's quite a cool feature as well. And you can see here that we have security. So Ben, you've done a bit of work, well, a lot of work with security as well.
Correct, yeah. So that's just the web application firewall, and how you can do it. There's a whole bunch of options. You can either have an IP allow list or geo-blocking by region. So just many ways that you can configure the firewall. And it's just like any other ACL, you just trickle down. If you're on this range, allow. If you're on that range, deny. So that's how this web application firewall WAF works.
Yeah, and then I guess rule sets as well is quite cool. You can do some pretty tricky things in here if you need almost like workarounds or hacks. This is really good to make different send your traffic different places in different ways.
Yeah, this rule set is very much, think of it like an if this then that type scenario. So in this example, say if device type equals mobile, you might want to add a certain header, or you append a query string to be sent to your backend. So there's quite a few options that you can do. What we had done previously on this rule set was forcefully append a series of security headers that disallow cross-site scripting type stuff. So these can be used in many ways to alter the data that gets sent through, or remove. An example could be on APIs. Just using APIs as an example, you might be able to, in your front door, you're pulling a request from your backend server, and you want to strip out certain information. You can use this to append the payload that goes back. So just many things that you can do, I guess.
And this is actually the demo app that we made. So this is so if we can see back here in front door, let's go to the origin group, and we can see that at the moment we're sending traffic to the primary region, the secondary region. And then if we go 50-50, that will choose which one it goes to. So it would go to primary and secondary. So you can see this is working. So we're putting all the traffic to the secondary region, and that's an environment variable that that validates that. And then if we were to change the weight or put it active, we would get primary when we hit it as well. So you can see that the traffic is routing to both regions. So that's sort of, we can supply this code as well for the Kubernetes side of things as well, if anyone is interested to play around with this and test out the multi-region as well.
Have we got any questions thus far on what we have talked about? So we've talked a bit about front door, we talked a bit about Kubernetes and how we're flipping between regions. Any questions at all? No, all good.
Okay, let's keep going. So that's front door. We can talk. Let's talk a little bit about our private AKS cluster and the bastion and how we hook up to it. So this is inside it at the moment. Let me just exit out of this and I'll show you how we did it. So we can connect to the VM using Azure Bastion. And what we've also done as well is that we've disabled password authentication and we only use SSH key, but with our automation in Terraform, we make the SSH key and then we inject it into Key Vault. So then we don't have to remember passwords and stuff. And then we add the access policy for the Key Vault so that, administrators like me can come in and then connect to the cluster if we want. So it's quite neat. We just choose our subscription, the Key Vault, and then the secret, and then connect. And that will use the SSH key to log in. So you can see here, now we're here. We're VPC with the private cluster with a private endpoint, and then we can do whatever we want, for a way. And this is on both regions as well. So you can see we have Argo installed on this one. Yes, we're using Cert Manager, Nginx for the Ingress controller at the moment. So when we go to Linkerd or something, we'll have to do possibly a little bit of changes in front door just so that works talking together.
I guess just to reiterate why we're using Bastion, it's because our Kubernetes service is a private cluster, which means on your local machine or any local machine, we won't be able to actually connect into it. So that's why this VM with Bastion in it is essentially a jump box that gets peered into it that allows us to make any changes if and only when necessary. But for the most part, as Brad had mentioned before, it's something that Argo CD would manage for us. If we make any changes in the Git repos, it will get propagated across to the clusters.
Yeah. And yeah, it works quite well with us. In the dev clusters, it doesn't need to be private. I mean, all the developers can just do the CLI AKS get credentials and get their context merged in. So it doesn't restrict them as much, because if you're a developer, this probably could be annoying having to go into the jump box all the time. But I quite like it. I get used to it, and it's good having it automated to be able to spin it down as well, so it doesn't cost money. So that's the Bastion. Key Vault's pretty straightforward. That essentially at the moment that just holds a SSH key, and we can use that over the clusters if we have secrets for apps, or you could use HashiCorp Vault or something as well. And container registries, we use similar to that as well. So all of our images we put into ACR, Azure Container Registry. And yeah, let's have a look at the cluster. So you can see this is the API server address as well. So it's a private link that not accessible in the outside world, using Azure CNI, Calico for the network policy. When we deploy this, just gives us the latest version of Kubernetes. One thing that we'll probably look at in Spike as well is pod identity. We haven't quite done that yet, so that's something on our radar to check out as well. And yeah, that's the cluster.
Well, I guess now that you did mention pod identity, let's elaborate a bit on what would you do after you've implemented pod identity? What would you be able to connect to?
Yeah, so if we look at against pod identity, so yeah, this is still in preview. Oh, yeah, so you need the AKS preview extension. You have a maximum of 200 pod identities. Yeah, I didn't realize it was still in preview. Actually, it's been out for a while, and you can see that you need that Azure. So you can normally you have the choice of Kubernetes or Azure. So we're using Azure at the moment as well. And I'm just looking for a diagram to talk over. It will be easier to explain. But it's essentially we deploy that into the cluster, and then that works with AD as well. I'm not sure if you need a premium Azure Active Directory, but let's try and there's a diagram that's probably better actually. Probably this one here, Ben. So here we have Active Directory. Pod identity uses the Azure assign ID to obtain the token on behalf of the pod. So this looks like here it will be a deployment inside the cluster, and then the identity establishes the identity of the pod and obtains Azure assign identity of that pod. And then, so the pod will talk to that pod identity and then get the token, and then it can use that to talk to like things outside your cluster, like Azure storage, SQL, could also be Key Vault or any service really. So it's sort of, I guess it's almost like, I don't know if it's the right way to explain it, but like a role for a pod, like that's assigned. So
yeah, it's giving
that could be
back to
quite
the pod,
interesting.
yeah.
Exactly, yeah. It's, yeah. So you can see here that, yeah, there's a lot of words going on here, but essentially it's a way to
The pod
authenticate.
retrieves the secret from the key vault rather than potentially you grabbing a secret from key vault and passing it as an environmental variable. It's just that way. It's always just grabbing it from the key vault in one location.
Yeah, and then it's like you don't have to like hard code connection strings and stuff in, because the identity will validate that yes, you can get that key. So yeah, this is that's probably something that we can experiment with next. It's quite cool. We don't generally talk to too much Azure services outside the cluster anyway, but
if you need to, the options there,
yeah, it makes sense. And yeah, did you have any other things that you wanted to talk about, Ben?
Not really, not at the moment. So that covered most of what we would actually do for our multi-region front door scenario. Because for the most part, what we're doing is we're just pointing it down from front door into Kubernetes, and a lot of the heavy lifting is actually done within the Kubernetes service itself. So for what we need out of this talk, it's mostly just how to get front door to pass the right traffic all the way down, which, as we had demonstrated, you have a CNAME where in the earlier example, it was reactor.brad.mccoy, and that gets passed through the routes and down into the origin group, which points into the Kubernetes cluster itself. So if you're creating different services, more things that you want in the Kubernetes pods, you're essentially just replicating that process. Instead of reactor dot, you just create a new thing like what we had shown earlier, x dot, and that just gets passed all the way down into Kubernetes.
And what are some of the best things that you've learned on this journey with Kubernetes in general and multi-region?
Multi-region is actually just really cool. It just depends on how you want to do it. What we had encountered thus far was that we are not at the scale that we would need active. We'll just do an active standby, which is quite crucial for businesses in the fintech industry, which, as Brad had mentioned earlier, if you have a credit card and you try and tap on it and it gets rejected, that's not a good look. So you just always want to have a disaster recovery plan in mind. And front door is pretty key to having that. Otherwise, how you code your endpoints, you always want to code it to one specific, reactor dot. You don't want it to go to reactor dot primary, and when that fails, you change your endpoint to reactor dot secondary. So having this single endpoint, nothing changes. It always just works, whether it's in region 1 or region 2. The customer doesn't even need to know that there's a second region in there.
Yeah. And would there be anything that you would change, what you know now in the planning stage? So maybe around, the architecture, what things would you change knowing what you know now in the planning zone? Would you recommend people starting off on this journey?
It's quite essential to get everything Right. So I would plan it all out. You got your whole one region stack, and then replicate it to region 2. Don't sort of piecemeal a bit here, a bit on region 1, a bit on region 2. Just get it all ready. And if you have infrastructure as code, that makes it a lot easier, because you know for sure that whatever you deploy in the first region gets replicated one-to-one to region 2, rather than if you had 2 files, for example, you could have some drift in your files, and all of a sudden you're not getting the exact same results when you go between the 2 regions.
Yep. Yeah, cool. And I guess, do we have any other questions for anyone? That's probably what we wanted to talk about today.
Mm-hmm. Yep. And yeah, that's basically what we have, I suppose. Yeah.
Great. Thanks, Brad. Thanks, Ben. I guess you've answered all questions throughout your presentation. We'll give everyone just another minute to see if they wanted to ask any questions through either Learn TV or YouTube. But just a reminder that I've put in that check-in link, and I believe Brad mentioned that he's got another link to share. So we will upload that one to the check-in link for you all. So you'll be able to access that one with the event code 14256 within probably the next 10 minutes or so. And we've just put in the link to the survey as well with the same event code, and then a link to the YouTube channel. So if there's anything you'd like to refer back to from today's session, if there's anything you missed, you can go check it out straight after today on the YouTube channel. We don't appear to have any questions come through, so we're going to wrap up early. Thank you very much again, Brad and Ben, for joining us for part 2, and thank you to everyone for tuning in. Have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event.
Thank you very much. Thanks for having us.
Cheers.